So welcome back again. So now we are looking at contra contrapositive proof. We are looking at contrapositive proof. So with this one, actually, this is how it works. Instead of proving that P implies Q directly, here we use you prove the contra. You prove the contrapositive. You prove the contrapositive, which says the negation of Q implies the negation of P. So what does this mean? Obviously, the negation is an opposite of a proposition or a statement, right? So if we are saying P implies Q, so the contrapositive would be the opposite of Q implies the opposite of P. And since here we're moving from P to Q, but when you're looking at the contrapositive, we are moving from the opposite of Q to the opposite of P. So this is very important. So let me just give you an example. So with an example, we are saying if 3n plus 2 is odd, and then n is odd. Simple statement. If 3n plus 2 is odd, then n is odd. So if you want to prove using contrapositive, we are going to do what? We are going to state this as if n is even, which is the opposite of what we are given here. If n is even, then 3n plus 2 is even. So do you see what happens here? So here we had P implies Q, right? 3n, we're saying 3n is odd, that's P. Then n is odd, this is Q. But then now if we are taking the negation of this, or the contrapositive, this is the same thing as saying the negation. This is saying the negation of Q implies the negation of P, because the negation of Q here is what? The negation of Q. So if Q state that n is odd, then the negation of Q is what? N is even, right? So again, if we are saying if P implies that 3n plus 2 is even, then the negation of P is what? It's going to imply that n plus 2 is odd. It's the opposite, right? We did negation. So that's what the statement is. Originally we're given a statement 3n plus 2 is odd. If 3n plus 2 is odd, then n is odd. Using contrapositive, we're going to reverse the statement and say if n is even, then 3n plus 2 is also even. So this is how you prove again. So now after you have written your contrapositive statement, you need to write your hypothesis. You need to write your hypothesis. You need to write your hypothesis. from my hypothesis here is I'm going to assume, so my hypothesis will be, I'm going to assume, so now I'm going to prove. So I've written my contrapositive statement that if n is even, then 3n plus 2 is even. If I can prove this statement automatically, I have proven this statement. That's how contrapositive works. So your proof will be assume n is even, and we know that we represent an even number using 2k, right? Where k is a member of real integers, and since we are assuming that 3n plus 2 is even, that means 3, where there's n, we have 2k plus 2, since n is even, right? So which means 3n is also even. So this is how you're going to represent it. And then this is 6k plus 2. So from here, we need to represent the statements in this. We need to represent the statements in this format so we can prove that 3n plus 2 is true. So this can be, if I factor out 2, I'm going to have 3k plus 1. So now I have represented 3n plus 2 in this format, which means 3n plus 2 is even since k is an integer. Since k is an integer, and also 3k plus 1 is an integer. So by proving the opposite of the statement, we have proven the statement itself. So here we are given that if 3n plus 2 is odd, then n is odd. But we proved the opposite of the statement using the contrapositive. By proving the opposite of the statement, we have already proven that the statement itself is true. And you should be careful when you're using the contrapositive. So we started with saying if 3n plus 2 is odd, then n is odd. And then now the contrapositive will start with the negation of n, or with the negation of q. So we are saying if n is even, which means the negation of this, then 3n plus 2 is also even. So this is how you go about the contrapositive proof. We can also look at another example. Let's look at another example, example 2. So with example 2, we're just going to say let n be an integer. Let n be an integer. And then we are going to say proof that, I'm going to use the sort of like the same expression, proof that if 3n plus 2, or let me just say proof that if 3n plus 7 is even, then n is odd. So we are given the statement. We need to prove using the contrapositive. So the first thing that you do here, let n be an integer. This is p, which implies that q, which is 3n plus 7, is even. So from here, what do we do? So your proof, first of all, you write, you can use the you need to represent the entire statement using the contrapositive. So when you're using the contrapositive, writing the statement in a contrapositive form, you're saying if this p of x is even, then Q, or not P of X, let me just say P because it's a proposition. This is 7. If 3n plus 7, which is P, it's a proposition, implies Q, our Q is what? N. So we are saying 3n plus 7 is even, then n is odd. So using contrapositive, we are just going to say, now we are taking the negation of this. We are going to say n is even, and this implies what? The contrapositive of 3 of P, which is 3n plus 7 is odd. So if you can prove the statement, the sentence statement is automatically true. So from here, with your proof, you make your assumption, your hypothesis. Assume that n is true. Assume that n is true. If we are assuming that n is true, we know that n is equals to 2k, right? Where k is a member of all integers. Where k is a member of all integers, and then since we've assumed that n is true, that means since we've assumed that n is even, sorry, not true. If n is even, then automatically that implies 3n plus 7 is odd. So we need to prove that if n is even, 3n plus 7 is odd. So how do you prove that? So we are given 3n plus 7. This means this entire statement should be odd if n is even. So this is 3, where there's n, you have 2k plus 7. And then if you simplify this, you're going to get 6. You're going to get 6k plus 7. 6k plus 7. So if we have this, now we want to represent, since we are saying 3n plus 7 should be odd, which means we want to represent this as in this format, 2k plus 1, right? So how can you represent this in this format? So what am I going to do here? I'm going to say we have 3n plus 7, which is equals to 6k plus 7. This is equals to 6k plus 6 plus 1. I've split 7 into 6 plus 1, and then from here this will be if I factor out 2 from the first two terms, I'm going to have 3k plus 3 plus 1. Now I have represented 3n plus 7 in terms of 2k plus 1, which shows that 3n plus 7 is odd. So therefore, or I can just say since k is an integer, then 3k plus 3 is also an integer. That means 3n plus 7 is odd. So by proving this contrapositive statement, we have automatically proven the original statement that you were given. So this is how you prove a mathematical statement using the contrapositive. So this was the last example that I had. So in the next video, I'm going to talk about proof by contradiction, which is another unique proof that is very crucial when you're looking at discrete mathematics. So thank you for watching.